So, have you ever actually stopped to wonder what really happens inside your body, literally hour by hour, when you just stop eating? I mean, we spend so much time obsessing over exactly what we put on our plates, but the science is increasingly telling us that when we eat, and more importantly, when we don't eat, might be the ultimate key to our health. Welcome to This Explainer. Today, we are mapping out the fascinating biological timeline of fasting, and we're really going to zero in on the mechanics of fat burning and this incredible process of deep cellular repair. Let's get into it.
Okay, let's kick things off with a pretty simple question. Are you ever actually flipping the metabolic switch? Research shows that the median American eating window is about 14 hours long. Think about that for a second. That means from the very moment you splash milk into your morning coffee to that, handful of popcorn late at night while watching TV, your body is just constantly processing incoming calories. Because of this continuous 14-hour grazing cycle, most folks walking around today literally never flip their internal metabolic switch.
So here is our roadmap for today. First, the fed state baseline. Second, flipping the metabolic switch. Third, the hormonal cascade. Fourth, the autophagy timeline. Fifth, beyond 16 hours. And finally, number 6, optimizing your fast.
All right, diving right into section 1, the fed state baseline.
Take a look at this top graph, which basically represents your typical Western eating pattern. See those lines spiking over and over? That's your blood glucose shooting up with every single meal and snack throughout the day. Now look below that. You see a flat, lifeless line representing ketones, which is your body's fat-burning fuel. When your glucose stays high all day, your body has absolutely no reason to tap into its stored fat. You are essentially trapped in a cycle of constantly storing energy, but never actually mobilizing it.
To put it simply, your body basically has 2 fuel tanks. The default tank is glucose oxidation. When you eat, you store carbohydrates as glycogen in your liver and your muscles. It's super quick, easy energy. But the backup tank, fatty acid and ketone oxidation, well, that's where the real power lies. Fatty acids pack a highly efficient 9 kilocalories per gram. Compare that to just 4 for carbs. But here's the catch. Your body won't even touch that premium fat fuel until the easy glucose is completely gone.
Which brings us to section 2, flipping the metabolic switch.
Picture this. Hour 0. You just took your last bite of food. For the next 12 hours, your digestive system finally gets to take a break, and your body starts aggressively burning through its stored liver glycogen. As those liver stores start to run dry, a sort of biological tension starts building up. Your body absolutely needs a new energy source to keep your brain and your organs running smoothly, so by hours 12 to 16, it's forced to adapt.
And this is the exact moment we hit the metabolic switch. This is defined as the body's preferential shift from utilizing glucose to using fatty acids and ketones for energy. Now, depending on how active you are and what you ate last, this critical shift typically kicks in somewhere between 12 and 36 hours after your last meal. And guys, this isn't just about weight loss, it's a fundamental rewiring of how your engine runs. Let's look at the chemistry behind this in section 3, the hormonal cascade.
Behind the scenes, there is this massive, complex interplay happening. When you fast, insulin, which is your main fat-storing hormone, just plummets. This is basically the biochemical green light telling your fat cells, hey, release those stored lipids. At the exact same time, your body pumps out growth hormone to protect your muscle mass. Honestly, it's a beautifully synchronized system, perfectly designed for human survival.
Let's break down those specific biomarkers really quick. Insulin goes down, right? Which is great because it improves your overall insulin sensitivity. Meanwhile, human growth hormone spikes, and we're talking sometimes up to 5 times higher on longer fasts. Adiponectin, a hormone that regulates glucose and breaks down fatty acids, also increases. But get this, here is a really surprising fact. Free testosterone can actually decrease temporarily during an extended fast. Why? Because your body is smartly reallocating its energy away from reproduction and pouring it directly into cellular survival and repair instead.
Moving right along to section 4, where things get incredibly cool, the autophagy timeline.
So the word autophagy literally translates to self-eating. Sounds kind of scary, right? But it's actually your body's brilliant internal recycling center. It is a mechanism so incredibly crucial to human health and longevity that the scientist who mapped out its exact mechanisms actually won the Nobel Prize in Medicine back in 2016. Basically, when your cells are starved of external nutrients, they start looking internally for fuel.
Here is exactly how this microscopic cleanup crew gets the job done. Step 1, your cells go on patrol and identify damaged proteins, old organelles, and just general cellular junk. Step 2, they form a membrane called an autophagosome to basically swallow the garbage up. Step 3, they merge with lysosomes, which act a lot like tiny biological incinerators to degrade all that junk. And finally, step 4, the broken down macromolecules are recycled to build fresh, brand new cellular components. It is literally anti-aging happening at a cellular level.
So what happens if we push the clock a bit further? Section 5, beyond 16 hours.
Let's map out this accelerated timeline. From 16 to 24 hours, fat burning really ramps up and autophagy initiates. But the research shows that meaningful, deep autophagy really accelerates between 24 and 48 hours. By the time you hit that 48-hour mark, you are in an absolute state of peak autophagy and massive cellular regeneration. The full body perks of this prolonged metabolic stress are profound. We're talking deep cellular cleaning across the board. You enter a state of high ketosis, where ketones actively protect your neurons. Systemic inflammation drops way down. And incredibly, fasting boosts a protein called BDNF, brain-derived neurotrophic factor. Think of BDNF as basically Miracle-Gro for your brain. It promotes the growth of new neurons and seriously sharpens your mental clarity. Okay, let's get practical. Section 6, optimizing your fast. Preparation is absolutely key here, you guys. To ensure metabolic flexibility and, frankly, just avoid feeling totally miserable, you need a strategy. Taper your calories slightly 2 to 3 days before attempting a longer fast. Hydration is completely non-negotiable. Aim for pale yellow urine. Focus your final meals on nutrient-dense proteins and healthy fats, and gently bump up your fiber. And crucially, limit sugar and alcohol beforehand. Seriously, if you don't, that initial blood sugar crash is going to make those first 12 hours absolutely unbearable. Now, what about exercise? You definitely don't have to just sit on the couch while you're fasting. Early in your fast, stick to light yoga or a brisk walk. But here is an amazing optimization hack. Intense workouts like high-intensity interval training or heavy lifting are actually incredibly effective right at the end of your fast. Why? Because your glycogen tank is completely empty, meaning your body is forced to fuel that intense workout almost entirely by burning pure, stored body fat. Now, as your guide through this explainer, I have to objectively report the medical caveats here. Extended fasting is a major stressor. So while the biological benefits are vast, it is definitely not for everyone. Pregnant or breastfeeding women, growing kids, individuals with a history of eating disorders, or those with certain medical conditions like type 1 diabetes should avoid extended fasting entirely. You know the drill. Always consult a professional before pushing your physiological limits.
But for healthy adults, the efficiency of that flipped switch is just staggering. Take a look at this. By the 24-hour mark of a fast, a massive 65% of your entire body's energy consumption comes directly from fatty acid oxidation, fat burning. Only 20% is coming from residual glucose and just 15% from protein. Your body completely and fundamentally rewires its energy grid to keep you thriving.
Look, if you try a 16-hour fast tomorrow and it feels incredibly difficult, don't panic. Consistency is key. Adapting to this physiological timeline is exactly like strengthening a muscle at the gym. Your metabolic flexibility, which is your body's ability to seamlessly transition from burning carbs to burning fat, improves the more you practice it. It just takes a little bit of time for your cellular machinery to remember how to do this efficiently.
So we've journeyed all the way from the fed state. We flipped the metabolic switch, surfed the hormonal cascade, and unlocked the absolute cellular magic of autophagy. The science clearly shows that just giving our digestive system a break unleashes some of the most powerful healing mechanisms built right into our human DNA. So I'm going to leave you with this provocative question to chew on, pun intended, the next time you reach for a late-night snack. Are you ready to finally stop the clock and give your body's internal recycling center the time it actually needs to clean house? Thanks so much for joining me on this explainer, and keep learning.